Alright guys, in the previous video, we saw how BFS works. In this video, we are going to implement it. Now, to implement BFS algorithm, I am going to use variable called color in my vertex class. And notice that I have restricted the value that our color variable can hold by making its type to a node color, which is enum with values white, gray and black. So our color variable will only be able to hold either of these values. Now in simple graph class, I am going to add friend function called BFS, which takes reference to a graph and integer as argument. Now I will be implementing our BFS algorithm inside this BFS function. Actually, you can either add it as a member function for simple graph as well. In that case, you can omit this reference. Now inside my BFS function, here first I have my QData structure. Before starting our algorithm, we have to do two things. Since we are providing source vertex as integer, we have to first find the corresponding vertex object. And also we need to set all vertices, color, distance, predecessor variables to its default value. So both those tasks will be achieved by the initialize and find vertex function. So inside the initialize and find function, we are iterating through all the vertices in the graph and setting each vertex color to white, distance to -1 and predecessors to null. And of course, if we found vertex with the given vertex ID, then we are assigning that to variable called v1 and returning that. So in that way, we can do both initialization and finding particular vertex with given vertex ID in one iteration. So let me fall back to my BFS function now. Now inside the BFS function, after all this done, then I am going to push our source vertex to Q. And then I am going to iterate in while loop until our Q is empty. Now inside the while loop, first we need to dequeue the element from Q. Now for that we have to call both front and pop function on Q. Because front function will only return the first element, then we have to take it out from Q, therefore we need to call pop function as well. And then I am going to add each unvisited adjacent vertex of U to our Q. Now if you remember, our vertex class adjacency list is list of pair. So the first element of that pair will be our particular vertex. So we have to verify that it is an unvisited vertex. If so, we are setting its color to gray to indicate that it is visited now, and then we are going to push it to the Q. Now also notice that we are here setting distance and predecessor variable as well. Now by setting this predecessor variable, we are constructing the predecessor subgraph for this particular graph for this particular BFS call. Predecessor subgraph is very important to understand the structure of graph, as you will see in the upcoming videos. Now after iterating through all the adjacency vertices, then we are setting this U vertex color to black to indicate that U is done now. So that is how we can implement the breadth first search or BFS in C++. So that's it for this video. See you in the next video. Thank you.